Okay, let us get started. I will request all the speakers to come online. Good afternoon, good evening to all of you, dear members, guests, and colleagues. My name is Rajshekhar Malur. I'm the Governing Council member of Consulting Engineers Association of India and also the chairperson for the Southern Regional Chapter of CEAI. I head the power business at Tata Consulting Engineers, and welcome to this 5th CEAI Golden Jubilee webinar. First of all, we do hope and trust that all of you, your families and colleagues are staying safe and healthy in these challenging circumstances. The situation appears to be improving amidst this warning of an impending second wave. Please do take care and stay safe. So as you are aware, CEAI is celebrating 60 years of service to the engineering fraternity, consulting engineering fraternity in this year. And in keeping with our aims and objectives to improve the knowledge and also the level of engineering in India and also Indian engineers at large, CEAI has been organizing this webinar series. The 5th webinar in this series today is on digitalization in engineering. I was glancing through Economic Times this morning, and in the front page, top right corner was Satya Nadella's picture with a statement that Digital India made the country stand out. It was pointing to page 6 on disruption, startups, and tech. And there were all news items on Facebook and Google and Amazon and Tech Mahindra, and statements such as quality of companies coming out of India are world-class. Cloud and AI driving growth in this pandemic season, and so on and so forth. Consulting Engineers Association of India, being the mouthpiece of consulting services companies, there is no better time to talk about digitalization than now. Digital is cutting across industries, it's cutting across domains. And one of the profound statements, and also a little controversial statements, I would say, is that in this digital world, technology overtakes domain expertise, which means you don't need physics, you need data. And when we were students, we have seen these empirical formulae, right, which were based on observation and also experience. And today that is getting replaced by data. So we as engineering consultants, consulting companies have depended on our domain expertise for our bread and butter. And how should we and how are we reinventing ourselves in this fast changing world? And what changes are happening in the consulting industries, and specifically as India approaches the 75th year of independence, how the country is embracing digital, and as engineering consultants, how we are enabling it. And these are my thoughts as we start the discussion today. And in this session, we will have 3 keynotes titled Engineering Digitalization and Innovation Driving Industry 4.0, the role of artificial intelligence and machine learning for successful Industry 4.0 implementation, and the GE Digital Industrial Experience. And we have 3 eminent speakers to deliver these sessions. We have with us Mr. Amit Sharma, Managing Director, Tata Consulting Engineers, Mr. Sudhish Narayanan, Chief Executive Officer, Knowledge Lens, and Mr. Alok Nanda, CTO, GE South Asia, and CEO, GE India Technology Center. We are extremely thankful to these gentlemen for giving us time amidst their busy schedules. And I feel proud to welcome you, Amit, Sudhish, and Alok. We are very eager to hear your thoughts. And after these 3 keynotes, we will have a panel discussion with the speakers, and you are open to send the questions to us, audience. And I request you all to please send your questions in the Q&A window that you see at the bottom, and do not please use the chat window. That is a request. You are requested to send your questions in the Q&A window. So without much ado, let us get started. And I will request our immediate past president, Consulting Engineers Association of India, Mr. Amitabh Ghoshal. Welcome to you, sir, and I will request you now to make your opening remarks.
Thank you. Thank you, Dr. Malur. It's a pleasure to participate in this very topical webinar, Digitalization in Engineering. You see, digitalization has started quite some time back, and it was progressing, but perhaps in a slow pace. Ironically, it is the pandemic which made everybody look up and try to find out how one can still function in this lockdown situation. And digitalization provided us with the way out. You know, particularly in consulting engineers, we had all been taken over, we were all being adapting digitalization and looking forward to be more on the digital platform. But all of a sudden, in March, April, when the lockdown came, we had to be sort of forced into action. And over the last 8 months, there has been tremendous change in every organization, and particularly the consulting engineers who are tremendously dependent on communication. Communication back and forth and immediate adoption. And that way, digitalization has come with a big third, and we have all got to adapt to that. Keeping that in view, Consulting Engineers Association of India took upon itself to not only educate and support its own members, but the entire engineering fraternity. And we had held, out of these 5 webinars which we have held, 3 have been directly on the aspects of digitalization. We helped first our members to take over to the new mode, new platform, and we helped them, we held their hands, not only our members, but all engineers. It was free for everybody to move to work from home concept in a smooth and efficient way. Then we had a sort of tutorial session, I would say, on the modes of digitalization, the results of digitalization, with all these esoteric names, AR, VR, AI, ML, everything explained. And today we have come to a topic which is digitalization in engineering. And I am sure the participants, and you will all be happy to know that there have been more than 300 registrations for this event. And we look forward to a large group of participants through the webinar. And it gives us great pleasure to be able to share the thoughts in this area with the help of 3 very eminent speakers who have been assembled by moderator Dr. Malur. You see, CEI stands for the consulting engineers, but we have taken ourselves a little more forward. And since consulting engineers form the apex of the pyramid of engineering per se, we decided that whatever we do should be applicable not only for consulting engineers, but for the entire engineering fraternity. And whatever we do and whatever we sort of spread should relate to the engineering fraternity, which has to find its place in the country. It's unfortunate that in our country, even today, engineering is not yet recognized as a profession, and we still don't have an engineer's bill, towards which we are trying our best, and we hope to see the engineer's bill a reality in a short time. With that, I will thank all the participants for joining us, and we would request you to give your feedback, and we would also request you to participate in the question answer session and make it a lively, interactive webinar. Thank you, Dr. Malur. I hand it back to you. Let us get started on the real event. Thank you.
Thank you, Mr. Ghoshal, for introducing CAA and also welcoming all. And I will request the audience to start, writing down your questions in the Q&A box, so that we have a sufficient number of questions towards the end when we have the panel discussion with the speakers. And please, once again, I request you not to use the chat box. Our first speaker today is Mr. Amit Sharma, Chief Executive Officer and Managing Director, Tata Consulting Engineers. And being from TCE, I can proudly state that Amit has transformed a traditional design engineering company into a truly digital company. We now have a new horizontal term, TCE Digital, which cuts across all our verticals. And all our internal systems and processes are today digital, thanks to Amit's vision. Amit will be speaking to us today on engineering, digitalization, and innovation, driving Industry 4.0. And over to you, Amit.
Thank you, Raj. Thank you, Goshalji, and welcome and good afternoon to everyone. It's a pleasure talking about the aspects of engineering and how digital is a key part of this entire story. I just want to confirm that you can see my presentation online.
Yes.
Okay.
Yes.
So congratulations to CAI, which has anchored the consulting engineers as an organization in India. And we've had some really good webinars over the last couple of weeks and months. Today being the digitalization engineering, I'll talk about what are the areas where engineers need to reinvent themselves, learn new things, and continue to do the best they do. I think we are amidst a great moment where with Industry 4.0, this is the first time that engineers can truly become the center of transformation as well as re-engineering of not only organizations, but entire value chain. However, the proof is in the pudding. So before I start, first I want to say that thanks to all the engineers who've shown resilience, quick learning over the last few months, and most of the consulting organizations have continued their work from home, and our engineers are doing a great job of ensuring collaboration, teamwork, use of digital to enable our work that needs to be delivered to our clients, not only in India, but to clients across the world. An example of the work we did as part of the Tata obligation to work across India. And before I start, what you see on this slide is an outcome that was born during the last 8 months, conceptualized, designed, detailed, manufactured, and implemented on ground. As part of the One Tata collaboration, TCE, along with Tata Steel, Tata Projects, Voltas, Tata Trust, we all came together. And purely because of the collaborative nature of design, engineering, construction, and its implementation on the ground, what was initially called a standard Tata unit, a modular approach to creating a hospital design, which could be put at a site, at a platform, or near to an existing hospital, was realized within a span of few weeks. And this slide talks a lot about how digital working, the whole mindset of a modular approach, the whole mindset of trying to do innovative things, leveraging technology, collaboration, teamwork, we can create things in a very short time that can serve what the need of the hour is. And if this can be done in 2 to 3 months, I'm sure there's a lot of innovative work that our engineers can do across power, chemicals, refineries, transportation, and so many other sectors. But I thought it would be pertinent to talk about how each of this element that you see on the ground, from concept to commissioning, from 3D to 4D engineering to construction sequencing to logistics, transportation, all of this was simulated first, designed first, and then we got it done. And you can see elements of the fabrication by Tata Steel, elements of duct work, and the entire COVID wards designed by Voltas for cleaning the air, having an ambient temperature, for the entire logistics transportation by Tata Projects and its implementation on the ground, and the entire design being handholded and conceptualized by engineers at TCE. So engineers today really can drive a lot of innovation when challenges are thrown to them. So it's one of the most exciting times. We engineers have the power to visualize a change and with innovation, make it happen. And this is a very simple example, and I'll talk a little bit more advanced things, but I thought it would be pertinent to talk with this example. So what's happening in our world? We're not just seeing disruption because of economic cycles, which are becoming shorter because of the volatility, but actually the industrial value chains are under tremendous disruption and transformation. The entire supplier, manufacturer, distributor, customer value chain, the demand supply is for the first time changing from a push economy to a pull economy. What is a pull economy? Basically, customers are driving changes that they want. There are choices available in the market. The life cycle of the product or service is much shorter, just like the economic cycles of boom and bust are much more shorter nowadays. So we have volatility in the market. We have aging assets. A lot of capex cannot be put into these new projects, so we need to sweat the asset better. So existing assets have to perform to a higher level of efficiencies. There's a big generational shift. There's a big difference between engineers who could sit hours to make a drawing, an actual paper drawing, to the work we do with the new generation who has access to digital tools from school and college, to a knack for understanding new digital tools, designing in the shorter timelines, aligning with customer demands much quicker. And of course, the recent phenomena of COVID, where we believe the socioeconomic cycle and the political climate will most likely drive a bit of localization thrust and what we call as a reverse globalization, where countries will hedge their bets on what they build internally and what they buy from the global supply chain. And of course, there are other aspects. An example of industry value chain under disruption is automotive, where from engineers designing internal combustion engines, we suddenly have chemical engineers with batteries. We have electrical engineers with motors. From engineers in steel, metal, and mining using coal, we're talking about hydrogen becoming an essential energy element. From power, which was based on thermal, coal-fired boilers, we're talking about a complete shift to renewables, from solar to hydrogen to various other elements. And all this means amidst this disruption lies an opportunity for engineers to reinvent themselves, to think differently. And I think it's a great time for young engineers to really work with the experienced lot and to together create innovative solutions, what the industry is asking, whether it is related to decarbonization, whether it's related to green economy, circular economy. I think we have a tremendous responsibility to give back to society and our future generation a cleaner, healthier, and a sustainable tomorrow. And with that in mind, we believe that engineers, if they embrace the digital mindset of being modular, collaborative, and ensure leverage of technology, they can play a significant part in Industry 4.0. What are the key elements of Industry 4.0? We've had technology for last almost 20 odd years. The big difference is digital when it was used online with Amazons and whether it was Facebooks, etc. The key difference was it was for non-captive, and it's very successful. But when you talk about an industrial environment, when you talk about leveraging digital in a power plant, in a steel plant, or you talk about digital in a transportation sector, we're talking about a captive audience. And with sensors, artificial intelligence, tool sets that can look at patterns, there are ways to optimize the work, and the efficiencies can be increased of existing assets. So the key elements, of course, is big data analytics, asset performance, integrated command control, 3D printing, precast, prefab, smart sensors, asset digitization. And with this, we are able to better listen to the assets between humans. And of course, we have PLC and SCADAs of past, but we can now put intelligence to self-optimize, to do maintenance runs, and to connect the brownfield asset with the greenfield asset together. And by doing this, humans and machine can work together and have higher productivity, a better agility, and ensure that we are aligned to the shorter economic cycles. No longer can we have an ROI of 25 years for a power plant or a steel plant, because the cycles in the market, the metal commodities or the power is going through a big disruptions. You cannot make a model in automotive where a model will last for 10 years. We are finding that vehicles are changing every 2 to 3 years. So you have to be very nimble and agile. And I think Industry 4.0 allows that. And the engineers working, whether on the manufacturing side or the plant engineering, by embracing these tool sets, are able to marry the old with the new seamlessly. And that's why I feel the Industry 4.0, which is almost now turning to be Industry 4.5, is a great opportunity for engineers to embrace digitalization. So what exactly does Industry 4.0 provide? Well, we've got operational technologies and we have got information technology. And we as India, as a nation, has done extremely well in being at the forefront of the IT revolution in the last 20 years. Our engineers have worked across the globe in all industries to provide a very strong IT backbone. It's proud to say during COVID times, our IT industry has held and continued work seamlessly across the globe, whether it were banks, whether it was utilities, critical supplies, everything continued because of the strong IT backbone. And here comes the operational technology, which runs a plant, a utility outfit, or a railway outfit, or any other thing, water metering. And the coming together of OT and IT together is what Industry 4.0 is all about. And if you want to understand the key performance indicators related to your asset, and an asset can be a product, it can be a plant, you need to understand your asset, and hence you want to create an intelligent model of your asset. So you have a digital twin of what exists in the physical world and what you can see in the digital world, not just the 3D coordinates, but also sensors that track the data related to their performance, their fine tuning, their life cycle, their maintenance and replacement cycle. And we call that asset digitization. You're able to control these assets better because you would have command control. Beyond the project and plant that I talked about, these integrated command control centers are also in smart cities. Over the last 5 years, where we've worked very closely with the Government of India on smart cities, we've put these sensors so that you can do intelligent traffic management. You can provide better connectivity between multimodal transportation. And there also various apps to various traffic simulation solutions allow cities to not only control traffic, but better water, better electricity, and all these areas. So Right from asset digitization to command and control to performance, we are able to provide the right kind of understanding of the physical world in the digital world. We as TCE, over the years, almost 60 years, have done extensive work in the core sectors of power, hydrocarbons, mining, metals and resources, and infrastructure. And right from designing 90% of nuclear in India, working on metro projects, to working on renewable projects, to designing steel plants, chemical plants. The last 6 to 8 years, we created a thrust on digital and advanced technologies, where the thrust was how to reinvent ourselves. And while we work with the Indian firms that were progressive, we also work with the global firms. Now, I'm happy to say that it's because of the last 6 to 8 years of extensive work to digitize our offering, right from concept to detail engineering to construction management, we were able to seamlessly work and operate our sites and our projects during the COVID times. And barring a week, 10 days of work stoppage in March, all our teams have been working non-stop throughout our projects, whether at the site or in our offices or work from home, supporting our clients. So how does this happen? Is this something that can be done in a day? Not really. Digital mindset for our engineers has to be reflected in the digital mindset of the organization itself. And we embarked on this journey in 2014 amidst competition, amidst demand from our clients, amidst the collaboration with our clients, amidst collaboration with tools and technology player. Whether we were working with equipment OEMs like GEs and Siemens and Alstoms, or working with majors like NTPC, Aramco's, BASF or Tata Steel, or working with fellow consultants in India and abroad, the most important thing to create a digital workforce is to embrace digitalization within the organization. And I'm happy to say, over the last 6 to 7 years, we completely transformed that no paper would be signed for any approvals, whether you are at site, whether you're in office. And it was a journey of step-by-step transformation. It was not something that was done in a day. Of course, we integrated in our architecture the best of the technology, whether it came from Microsoft platform, whether it came from SAP, from Autodesk, from Wrench, from Aviva, and from various other tool sets. And also, we tried to project ourselves as a digital firm to the social media to attract the right talent, which thrives on making digital something standard. How do we make engineering and consulting supervision exciting for our young individuals and engineers? Unless we give them apps, unless we make their life the way they live, their personal life, which is based on smartphone, smart tablets, can we embrace smartphones and smart tablets in their professional life? So we did all these, whether it was design portals, site management tools, safety portals, all of this was digitized. And it served a unique purpose of enhancing productivity, enhancing quality, reducing errors, but also in aligning with the rapid shifts in technology and time to market required to do projects. Earlier, a project used to take 3 years in a chemical or in power. We had to deliver the same project in half of the time. And it couldn't have been done if we didn't create a digital architecture and make our engineers embrace the digital mindset. So my request to fellow engineers across on this webinar, this is an exciting time for us to embrace technology. And what we do in our personal lives is what we are doing in our professional lives. And it seamlessly allows us to work with high productivity, high quality. Under the Atmanirbhar scheme, unless we embrace the best quality benchmarks, the best productivity benchmarks, our country needs engineers to look at these benchmarks to become the best across areas that we do our projects on. So coming back to the future of design, construction, engineering, there's an interesting report on McKinsey which came few years back, but we are actually seeing it on the ground. The first example of the COVID wards I talked about is a prefabricated, it's modular structure. And that's what Future of Construction were talked about in 2016. We are seeing it today. Advanced building material using 3D printing. Already a lot of pioneering work has happened abroad. Even in India, there are startups looking at 3D printing of civil structures. Autonomous construction, LiDAR survey for static and dynamic assets is something already happening. We are doing LiDAR surveys for refineries, to alignment of transportation projects, to doing LiDAR survey for our mining projects, as well as brownfield and greenfield construction. Augmented reality for training workers on the ground, how to handle events that happen in plant, which could turn into a catastrophic event. People remember movies more than manuals. And if you can immerse themselves, these engineers, into an environment with augmented reality, they can actually simulate the actions they need to do at site in a critical timeline. Of course, big data, you can manage plants efficiently. With wireless monitoring and connected equipments, we are looking at optimizing plants in steel and power, and I'll walk you through some case studies. And of course, the entire building information model is revolutionizing how consultants, contractors, clients all work together seamlessly to make sure that projects are delivered in time. Just like in mechanical, we deliver products in time, how do we deliver projects in time? By combining these entities together. So here's an example of a refinery which has been there for 50 years. And in order to make it Euro compliant, how our teams have scanned this entire refinery. There was a lot of data that was missing. By scanning this refinery, how you create a 3D model, which is further reverse engineered. All the information related to the refinery and its components are added, either engineering drawings, P&IDs, individual assets, or any other unstructured data. And by doing all this, you create an intelligent refinery digital twin. And why is it important? Because it allows you to do better work when you're extending the capability of the refinery by adding new plugins. And it helps you minimize your CapEx cost. There has been a guaranteed CapEx reduction of 5 to 10% on new bids by contractors if you have a better understanding of an existing asset. So that's digitalization happening. Another on the refinery is how you look at the entire laser scanning to ensure that your refinery is compliant to the safety standards. You're able to train your workforce faster. You're able to optimize refinery outputs across multiple units by doing proper data analysis. And of course, this is a great example of, and chemical has always, petrochemicals and chemicals have always been at the forefront of optimization and control system. But even they are leveraging today's technology to further enhance. And there is time for us to embrace this in other segments like steel, power, transportation, and so on and so forth. We recently did a revamp in a steel plant in Europe, where a blast furnace was almost 80 years old with hardly any documentation available. And a blast furnace, of course, has a complex configuration of pipes, conduits, so many other things. How do we refurbish and revamp this without data? So we used complete laser scan, point cloud data, converted that to a 3D model. And we were able to do this project was initially planned for 3 years in less than 2 years. And that's significant, 33 months less, 33% less. The same approach on digital can be applied to any asset or to any project where we are trying to marry brownfield and greenfield. Of course, the ideas are limited only by the imagination. You can apply this to almost any other scenario where you're trying to marry the old world with the new world. On the 4.0 solutions, we are working with a lot of equipment manufacturers, not only to look at the reliability of assets, advanced maintenance strategies, what we call as asset performance management. So we work with OEMs very clearly. What are the diagnostics, predictive analytics, prognostics based on AI and ML? But how do we also provide a unified platform across multiple technologies? Because a plant is not a single technology platform. You will have different OEMs in a given plant. And we can look at data and provide a unified platform access. How do you add extra sensors? You might have SLAs being met at components of the plant, but the entire plant may not be compliant to the KPIs. And this is where new add-on sensors, which are much more optimized today, thanks to technology, maturity curve, rapidly making these sensors almost in cents rather than hundreds of dollars just 10 years back. We're able to use these smart IoT sensors to put intelligence into machine, which can get into the platform. And last but not the least, our digital workforce makes it exciting for the engineers to work at the plant, at the project site, and seamlessly integrate and immerse themselves using AR and VR with digital helmets to make our sites safe, predictable, and of higher quality. And this is all happening as I speak on projects across India and outside India. Here's a case study of the work we've done with a power client, where the problem was enhancing effectiveness of aging assets, especially as the efficiencies were demanded because of shift to renewable. You can't just retire existing assets from thermal, but you have to enhance their PLF and efficiencies. So how do we have better control on all related gaps and make it higher efficiency? How can you look at better workforce management? How can you look at a better solution that looks at the entire plant, asset information, condition monitoring, embed sensors in the plant so that it's more predictable and we can minimize unwanted downturns. And I think the benefits of this was not only were the efficiency increased, we were able to seamlessly synchronize it with other sources of energy that were required, especially when you're talking about a hybrid grid, where the sources of energies are not just one, but 3 to 4, from solar to wind to maybe thermal, and so on and so forth. Another case study on the power was based on creating specific solutions that were looking at point solution, for example, condenser monitoring, chemistry monitoring, performance optimization of all rotating equipments, especially pumps, and how these dashboards on smart tablets and smart apps are available to supervisors and managers, and also at the control center, and makes life easy for all the workforce in these plants. I think we can extend the logic. There's a lot of work happening in the water value chain with GIS mapping, remote sensing, looking at automatic AMR in water, reducing non-revenue water. We have close to 40 to 50% water wasted in urban areas as well as rural. How do we reduce it to global standards of less than 10%? And here sensors play a big role in making sure that water wastage is reduced. Happy to say that various government entities across states are working with us and collaboratively to leverage these technologies to reduce water wastage. And of course, the engineers on the ground, I must say, are coming with innovative mechanism to marry various technologies together to give innovative answers. Of course, the list goes on and on. We have multiple point solution in power, ranging from boiler modeling, coal inventory, solar power forecasting, transformer health monitoring, to hydrocarbons, about hazardous chemical management, heat exchanger monitoring, critical loops control systems monitoring. In mining and metal, looking at air quality, to dam monitoring, to analytics for better worker training in mining environment, to of course smart cities and water management. And it's going to grow from here. But this is not about working in a siloed manner. This can only happen if we work together as a community of engineers, whether you represent the client, contractor, or a consultant, or an equipment manufacturer. We all have to work together for making these solutions really give an output. And hence, the digitalization is a great opportunity, but it doesn't happen in a go. It follows a phased maturity model. There are basic things to be done. We then need to go to the next level. Then you need to look at digitalization at the plant level, multi-plant level, and then optimization. And the same story applies to an organization. We didn't embark on digitalization and getting our engineers savvy on digital, on 3D and 4D tools on day one. It took us 2-3 years to go on a step-by-step manner. And as I said, it cannot happen until we collaborate with equipment manufacturers, with our clients, and listen to their unique demands, listen to how their industry is transforming and being disrupted to an even more smarter and sustainable tomorrow. Towards the end, I'll just say digitalization is essential for all engineers. And whether you represent the client, manufacturer, contractor, developer, or consultant, I'm very fascinated with this, that the illiterates of 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn. And this is the best time for us to look at this quote and learn new things, maybe unlearn some of the old ways, and always ensure that sharing knowledge and collaboration with all entities is the only way forward. It is a must for us to make ourselves a digital engineer. There's a lot of thinking required. There's a lot of introspection required. There's a lot of changes required. We must embrace the change, and a new future will unveil itself, which is more exciting, more sustainable, more green. Thank you so much. With that, I hand over back to Dr. Malur.
Thank you. Thanks a lot, Amit. And I'm sure it's very encouraging for all of us, and especially our CA members, to see digitalization of the engineering value chain, right from concept to construction to commissioning of our assets, and further, how this will help in the OpEx regime. The same digital, twins, as you call, will help maintain the asset very well in the OpEx regime. So thank you so much, Amit, for your thoughts. And for the audience, I will once again request, there are already a few questions which have come into Q&A box. I will request all of you to start typing in and sending in your questions to us, and we will take them up after the presentations are over towards the end when we have the panel discussion. So I will now invite Sudhish Narayanan, CEO Knowledge Lens. I had first heard Sudhish in an ASCOM seminar, and hearing him is a learning experience, and he works across the domains. They work on failure prediction and smart devices, smart manufacturing, and further in the process industry, as smart energy management, smart environment management, and so on. And along with that, of course, big data, AI, edge analytics, blockchains, and so on and so forth. Sudhish will speak to us today on the role of artificial intelligence and machine learning for successful Industry 4.0 implementation. And Sudhish, the floor is yours. I'm sorry, the screen is yours now. Over to you.
Rajiv, and it's been an honor to be part of this session and sharing my views or my knowledge, whatever I have gained over the period of time. It's a little difficult over a webinar to do many things. In physical, it's a little bit different. But yeah, I'll try to do my justice to whatever I can. But I think at the outset, I want to thank Amit for setting such a fantastic overview on whatever the solutions are there. And I think it was mind-blowing outself. And I am sure that everybody who has attended this seminar would have learned quite a bit right from that session itself. In fact, I learned a lot from there. And thanks, Amit, for making such a good view of that. So what I wanted to do is try to bring how from the IT side of things, we look at it. And when IT and OT merge together, we creating the Industry 4.0 implementation, what we have seen as success and what we have seen as the trend which is coming through, and what is the experience which I've derived from this, so which we are able to go forward. So that's kind of my agenda today. I was not sure of all the audience, what's the background and so on. So I try to keep it a little higher level today. But yeah, I will be always keen to discuss the details behind it as well. But the key aspect and message which I wanted to drive is Industry 4.0 has been a buzz throughout it. Obviously, pandemic has accelerated it. Earlier, when the pandemic started, the whole story was that will the industry really want to spend the money in adopting to something like Industry 4.0? And as the pandemic evolved, I feel that the whole thing has shifted around 360-degree out. And we'll say that the whole way is that the digitization is the way to go. And we have seen quite a bit of engineering projects, Industry 4.0 projects being kicked out right away. And there's a lot of enthusiasm in the field right now on this basis. And from there, what I've realized is there is a common theme which is emerging across the board. And the common theme is that obviously data is the key asset, but leveraging data to create intelligence is what people are looking at. And even though we say Industry 4.0 and all the use cases, I think with Amit has presented out there, if you look at, go deeper into it, it is always taking that data and creating something valuable out of that data to create something unique. And I think that's what the whole story is all about. And when I looked at it, how do you create that value from that data? I see that traditionally we have done so many things on with data, but the advent of or the ease of ability to make artificial and machine learning has changed the game. And today's discussion, I just wanted to focus on some of those examples on how AI and machine learning is driving this whole Industry 4.0 implementation. Before I go there, just wanted to give you a perspective of what we are. I'm a 7-year-old company right now, not a big things around it. But yeah, from coming from a data and AI background, that's kind of our primary focus around. Focusing on many things. Again, Made India has been our focus, building softwares from India for the rest of the world. And that's kind of what I've been doing through. And with that is been always the focus around. So what do we look at as a digital transformation solution provider? I see that there are certain things which brings up this combination quite strongly. I'm not trying to market anything here, but I'm saying that if you look at from a holistic perspective, the engineering aspect has to come in. So that is the people who are on the field, the engineers, the automation engineers, the PLC engineers, the design engineers, the mechanical engineers, all of that has to come in together and then marry with the IT aspect of it, which is the AI and the data science aspect of it or the IT technology aspect of it. And when we marry this together with the domain experience is where the digital transformation happens through. So this is the usual slide I use for the marketing of the company as such. But I'm just trying to say that leave away the marketing part of it. But the basic fundamental is that each of these engineers are the key aspect right now. So today when I'm creating a digital twin, IT people cannot create a digital twin. What happens is we marry the whole thing from the domain experience. We bring the mechanical person, we bring the electrical people, we bring the design engineers on the ground, and then marry the IT part of it, bring the AI and IoT into it, and that's how the solution gets created. So more than enough right now today, as Amit said, it's the ability to unlearn and learn. That's kind of where it is making a huge difference, because as engineers we have done some things traditionally X, but today you need to really unlearn a few things and say that okay, there is a new way to do things. And I'll give you one simple example in this case. Every time I visit an industry and ask that, okay, I can do digital analysis, they say, okay, I already have my data, I am already sitting in my historian, what else can you do? I'm already doing analysis. The fundamental thing is what analysis you are doing versus what is capable, people are not ready to understand, because they think that okay, I've captured my data, I dumped in my historian, and I'm creating some charts. That's all it is, and that's what the capability is. But once you have the ability to unlearn and say that okay, let me experiment and see what value out of that data can be brought in, the game changes. And that's kind of where I see that there is a very, very important thing where we need to understand as a team to see that, yes, it's all about unlearning and it's about adapting the new technology and adopting it much faster to make a difference. I think this is a slide which everybody knows it, what's the industry 4.0 and 5 things. But the key thing which I wanted to look at it is people start coining different terms, different terminologies as we did. But the fundamental from here on is data is going to stay. The insights from data is going to stay. And that's why 4 or 5 or 6, whatever it is, the powering engine is not going to be steam, it's not going to be electricity, it's not going to be electronics, but it's going to be the data. So the transformation of Industry 4 is all about data, and data is transforming the whole manufacturing level and creating a new revolution. And that's what is Industry 4.0 as per what we have seen through it. It's more about data and transforming it, and the rest of the things are required, but the data has now taken a pivotal point here and trying to drive the things. So that's kind of how we describe. Obviously, there are certain things which has changed. We have got too many of technology pillars right now, and this is the right time because all these technologies has now come together in synergy to create a difference. For example, if you're looking at telecom, the 5G revolution which is coming through created a wave. The cloud has matured itself. The data analytics capability has brought in. People have understood how AI and data science can be used. Cognitive intelligence has been made it as a service. So if you look at all together, it is a system where all these levers are forcing and coming together and trying to drive something unique. And that's kind of where the digital revolution is starting off. And why this is happening right now? Because now each of these technologies are affordable. It is not that these technologies were not there earlier, but the technologies was available to only a selected few. And today, because these technologies are now open, the digital revolution is starting off. And I think Industry 4.0 is now a reality. Now, when we looked at many use cases in the Industry 4.0, I'll try to give you 2 examples which drove me pretty solid around it. So one was a biscuit manufacturer. In a biscuit manufacturing process, the quality control was always a challenge. How do you ensure that the biscuit is baked to the right quality and get a control on that? Yeah, there are varied techniques around controlling the process itself, but still there is somebody who is visually inspecting and making a quality check around that. The whole concept became a digital revolution when we started putting cameras to it. And we say that, okay, we can eliminate this human being because there's a pandemic, I don't have people. How do I change the whole story around? Create a digital vision of that and try to run AI models to identify the quality of the story. So that's kind of how the AI starts coming into the picture. So we could have already digitized the whole story, but the value came in when the vision analytics came into place. We are able to derive the quality out of it and create a outcome immediately. So again, then people understood, okay, now I need to go to Industry 4.0 because data has a lot of value. If I can bring a kind of vision solution, I can change many things. For example, there was another example which we recently did is a cement bag counting. Simple example. If somebody says, okay, cement bag count, what's the big deal about it? I have done automation. I put a light switch around it and I can count laser counting. I can do a lot of it. And it's a very simple thing. But the challenge the customer is facing is that the cement bags doesn't come one after the other. They stand on each other. There is sometimes 2 or 3 bags stacked together. How do I do a digital counting of it? Again, problems comes the same. The existing automation technology is giving a little bit incorrect result. Looking forward, okay, what's the solution? AI came into place. We put a vision again, created a vision based as if somebody is looking into it and created a solution out of it. So now the design solution became AI enabled, and you are now getting into the next arena of things where AI is augmenting your intelligence on your automation. So that's kind of the second example, which I see that it's breaking a very, very powerful impact onto your solution altogether. So the key catch to this whole story is that automation felt that, okay, this is the end of it. But yes, once you start unlearning and learning new things, you say that, okay, there is a possibility. There is a new possibility. and a design possibility which we should always explore too. And that's kind of how the new set of use cases are coming through. So let's take the third most prevalent use case. Whenever Industry 4.0 is talked about, the most important use case which comes in all the time is predictive maintenance. Okay, I want to do predictive maintenance. And many people say that, okay, I can predict something, I can do, but what runs behind the scene? It is AI models and machine learning which runs behind the predictive models. So what does predictive maintenance really try to do? It is trying to find out your mean time before failure and trying to give you an advance notification before the failure occurs so that you can define your maintenance schedule right before it, so that there is downtime elimination and hence your productivity improves and everything goes off. So the solution finally revolves around data science and AI. So when I looked at most of these cases which are coming and becoming more and more popular, we realized that artificial and ML is driving those changes. And one more reason would be that the low hanging fruit without AI and ML is already done. As part of automation, we could have done many things and we have already done it. So when you are talking about the next revolution, you need to create something unique. You need to create some additional value, which is non-linear value. And to create that non-linear value is where AI and data science is coming through. So this is a kind of a thing which I just pulled it out from some place. But if you see that these are kind of technologies which are right now coming up and trying to create the factory of the future. So the design engineers has to really focus on robotics. Obviously, they are doing right now. But now the next generation is how do you control these robots and make them autonomous? So because I had a dream that after the pandemic, there was too much of shortage in the factory itself. And we have so many workers sitting out there. Why don't the system starts bringing these autonomous bots which could actually do many of these things automatically, and the plant engineers or technicians can sit in the control room itself and operate them rather than going down to the field checking for each of the walls, meters, and so on. And I see that that's the wave going forward. Things are coming out in US and other places. I think that these are really happening out, and India, I think we are trying to adopt these technologies around. So we talked about the augmented reality. Obviously, there are so many of those, especially on training, especially on fault prediction, which are really showing up in each of these items. Similarly, the sensor part of it is also very, very important here. Like we basically put any IoT sensors out there, but the sensors are only giving what it is sensing. Now, what is the power of IoT? You can put multiple these sensors, and using your design understanding and engineering understanding, you can derive what is known as virtual sensors. What does virtual sensors does? It actually derives a new kind of measurement using a combination of sensors to create a new revolution. And that's kind of where the industry 4.0 is heading towards. So putting sensors was something which we did earlier. Now what we are doing is we are trying to bring the engineering into it and managing all the sensors together to create something which is meaningfully output, which is a new sensor output, which is a virtual sensor output. Then that sensor is then put into the machine learning models and so on, so that the value of the machine learning models increases. Otherwise, the machine learning models have to work with the engineering part. You have to model that. All that is really gone through. So sensors, learning and unlearning again here is very, very important. People will say, no, I put the sensor. What's the big deal about it? It is not about the sensors. It's about the intelligence of coordinated sensors, which are going to make a difference. And for us as engineers, we need to understand that that is the combination. And for that to happen, you need to have a combination of sensors plus software, which combine together to create a value. And then clubbed with the AI and ML on top of it, you create a revolution. So that's kind of how I see how things are moving in the new world. And I think all of you guys also will appreciate in each of these constructs which I'm talking about, there is associated things. So this was kind of the list of use cases when I looked at what really use cases are prevalent today. And you can really see most of the use cases in the Industry 4.0 solutions which are working are primarily because they are driven by data. They are the use cases driven by data. So each of us engineers has to do two things now. One is to understand how to tap the data. Second, we have to understand the fundamentals on how to leverage and make the data useful to us. So this is and again, most of the questions the engineers ask is, I'm not from the software background. How do I learn these AI and ML technologies? It is not about that you need to know to code around it. It is not required. You need to code around it. It is about you have to understand what is the working principles of all of those, so that when you get a problem statement, you understand, okay, if I can do these two things, I can get this output, which essentially means all I need is a software engineer to come with me and I will tell him this is what needs to happen and he will make it happen. So this is how I'm seeing the industrial revolution happening and how engineers like you are going to create a difference. It is not that software engineers are going to make a difference here. It is only engineers who has the expertise on the field, who has the ability to take that learning unlearning process in place and trying to add value, which is going to create a different solution out there. So again, the whole idea of bringing all these use cases was only one thing, that the construct of all these use cases drive on AI and ML. And as engineers, we have to do only one thing: understand the principles and then apply into it. And then finally implementing the solution is not a very big deal. It's a very simple thing. So if you tell any software engineer to implement any AI algorithm, that is something which can be done very easily. But understanding the domain, making that happen is a critical aspect. So again, going back to, so people understand and say that, okay, how do I bring it all together? What does the solution should look like? So what I did is I tried to put this as a picture around it. So on the left side, you see the OT network, how data can come in from various places. So all you need is a place where the data is digitally available. If digitally not available, you convert it to digital. That's the only first part of this segment. Once the data is converted, what do? You store the data into the cloud or a local premise, whatever you want, and organize the data. That is the second part of the problem. And once that second part of the problem is done, see, the second part is very, very important, because using traditional systems to store this data is not going to change your game, because you need AI and others to run on top of it. And if you want AI and others to run on this, the only way you can do is organize the data in a much better way. And that's why you need the next generation platform. When you have this next generation platform, your organization of your data is good. Your running of these models on this becomes very, very simple. And that's kind of the secret of Industry 4.0. So when traditional systems are told that, okay, Industry 4.0 is difficult to implement, it's not because they cannot implement. It is because their data organization is so cumbersome that they have never thought about the next level. And that's kind of where we need to look at. So as engineers, only one thing you need to look at is how do you organize your data much better, so that different set of AI use cases can be enabled on it. And this is a kind of a architectural view I should give it to you, so that it becomes easier to do this whole thing. So this is, I have gone into a little bit of IT insiding so that you see what happens behind the scene. So if you see on the left side, it's basically devices which are pushing the data. There's something called edge appliance, nothing but it's sitting on the edge, trying to collect the data, push it down to the cloud. So what happens on the cloud side? All it does is it organizes the data, creates different sets of training models. It tries to run models on it, try to figure out whether the accuracy is okay or anything. Once that is done, then there are two options which you have. One is you can run the model on the cloud, or you can push that model down to the edge, because that decision is done based on whether you need a real-time intervention or you can do a batch intervention. For example, in the manufacturing line, you want to flag out the quality issues. for flagging out quality issues, you cannot use the cloud, because by the time the line is running, the data goes to cloud, runs the model, comes back, it is not going to work. So you need to run that model right on the edge. So now edge doesn't have so much of compute capacity that you can create your models and everything. So what happens is you push the data to the cloud, generate all your models on the cloud. Once a model is perfect, you push it down to the edge. So only the execution of those models happens on the edge. So this is a scenario where you have an edge appliance which runs the AI model on the edge and giving you inferences right on the edge. So whether it is quality identification, or whether you want to do a line control, or you want to do a automated sequencing control and so on using AI ML, this is a model which you can always do. So the large companies, what they do, they create the model, keep it with themselves in the pocket, and then finally give you a solution on the edge. But when you look at from the scalability perspective, every time you have to go and buy the model. But if you come to a model like this, then you have it all flexible. You can build your model, you can use your engineers, create your own unique stuff, and keep driving the story. So this is kind of the aspects which we are looking at. So I've talked about many of this technology, architecture, and so on. And I thought at the end, I will talk about the various analytics models which are out there, which we use in AI industries right now. So first, I talked about the predictive maintenance. I hope everybody understands that now. That predictive maintenance is all about predicting the failures of the machines, pumps, motors, boilers. You can look at ESPs. You can talk about any equipments. You can do a predictive maintenance. Now, predictive maintenance of two types. One, you look at the individual equipment. For example, there is a gearbox. You can do a predictive maintenance for the gearbox. But gearbox is not alone, correct? It's a complete system. So how do you do the whole predictive model of a whole system? So you build predictive models of individual systems, then create a super model which runs across all that, and then create a final model around. So that's kind of how we predict the failures of the entire system itself, even though the system has many, many subparts, and get it through. So this is a construct which is getting evolved. Traditional predictive maintenance is only done at individual items, smaller items. But I think now the time has come where we start looking at a bigger one and create a revolution in this predictive maintenance business. The second thing which I talked about is quality inspection. Everything in the line where human being is involved can be done very easily from machines, and AI models can really work out. Yeah, there are certain places where quality still needs to be checked by human being, but I think this is where the second biggest application of AI ML in Industry 4.0. The third place is the hazardous and safety monitoring. For example, somebody fell in a hazardous area. Who is monitoring? Okay, there's a vision technology which is there. There's a tracking mechanism for him. And how do you forecast all of those in a live environment? Even gas leak detections, those are kind of solutions which we look at from there on. The next part of it is vision. Vision-based sensors are very important. There's a lot of work which is happening in the Industry 4.0 in vision-based stuff. And I think that is another area of focus. There's a huge set of use cases around that. The last part of it is the optimization and forecasting. This is traditionally a lot of optimization and forecasting has been done through normal ML models. But I think that is coming to the next level with the advent of digital twin. So once you get the digital twin created, you are trying to pump live data into it, and the model will forecast and give you simulations and variables right out of that. So that's kind of the next level of use cases which are coming through. So I think I'm not sure whether I'm running out of time, but I'll take the one last slide and then I'll wrap it up. So this is kind of the holistic view of Industry 4.0. What does Industry 4.0 solution looks like? Obviously, you need a central command center, which is the unified web SCADA, we call it, where different types of heterogeneous control systems can be brought on a single window and created. Because this is a traditional problem with the industry today, where every manufacturer OEM gives their own SCADA. But when you look at the holistic view, there is no way we can bring it all together. So bringing a holistic way, a holistic control plane is very, very important. and that too not localized on a command center. It needs to be available in a very seamless way. So that is why it has to be available on the web, so that anybody like the plant head or the operation head or the chief marketing or manufacturing operations head, all of those guys can see it and make informed decisions. The second ingredient is obviously the security aspect of it, where you need to worry about the IT/OT security. So that's another ingredient of an Industry 4.0 solution. The third obviously is how do you bring the monitoring of each of the equipments, uptimes, operational equipment efficiency, and so on. So that's kind of it. Now comes the last fourth item, which is what happens is data enablement is on the platform. Now you can build different sites of AI enabled apps on that. So building a platform is very important, because you don't want to create siloed applications which are pointed solution focusing on one aspect of it, because then you will not realize the value of digital transformation. So you need to create different pointed solution, but on a common underlying platform. And that's kind of where we are looking at AI enabled apps. We call it as apps, not a pointed solution, because pointed solutions will not scale. If you have an analytical app sitting on a common platform, it just scales. So again, I've given the edge analytics. I've already given you examples on that. I've talked about virtual sensors, which you need to get from a digital twin perspective. And finally, you need to bring all your data assets, not only from the manufacturing, but also from your sales, logistics, and every aspect in a single plane, so that you can tap into that value and create a different experience altogether. So that's kind of unified analytics we are talking about. And obviously predictive maintenance is a super hitting solution. So that's kind of how you look at overall solution itself. There are many more things which you can do around it. I have so many other things, but I think in the interest of time, I'll leave it to you guys. This is my contacts in case you guys have to reach me out for anything. So thanks. Over to you guys.
Thank you, Sudesh, and for that views on the power of the engines going forward is data, and also highlighting the importance of AI and ML in handling this data and providing solutions. And I had this thought in the beginning of physics versus data, and domain expertise versus technology, and you very nicely talked about how they actually collaborate. And so thank you very much for your session. And we will now move forward to the third speaker. I consider it as a privilege to introduce Alok Nanda, Chief Technology Officer, GE South Asia, and Chief Executive Officer, GE India Technology Center. And I have known Alok for more than 15 years now, and I can bet he's a powerful speaker. This is Alok's second talk for CEAI. We had him in the 2019 international conference, FIDIC ASPAC, in Delhi last year. And he's been kind enough to agree to do this talk today. And his talk will be on the GE Digital Industrial Experience. And Alok, over to you.
Thanks, Raj. Just let me know when you can see my presentation.
Sure.
Is it visible?
Not yet, Alok.
How about now?
Yes, we can see. You can go to the slideshow mode.
Okay.
Thank you.
Perfect. Thank you, Raj, for the introduction, and thanks to Amit and Sudesh for setting the stage so well. Their talks have really laid the foundation for what I'm going to share now. What I have are a few examples through which I will not only talk about the opportunities when we talk about digital transformation, but also some of the challenges that accompany the transformation, so that all of us can appreciate what we've learned in GE and maybe take advantage of that as we deploy this in our own world and in our own industry. So let me start off with why this is such an important thing now. AI is not new. Machine learning is not new. I mean, of course, the techniques have evolved and algorithms have evolved and become much better, but it's been there for like 2 decades, maybe more now, in various forms. But what has changed is the fact that our computational power has increased, 11 terabyte operations per second. Okay, increased in connectivity. I mean, our COVID tested us, but wow, I mean, how it worked. Many of us could have productive workforce because of this connectivity. 4.5 billion people connected. And then increased data. I learned a new term, exabytes. I mean, it's like 1 billion gigabytes. So 2.5 exabyte data is generated per day according to an estimate by Forbes. So that's why if you think about all these things, and on the left hand side are the reasons why this is happening, because all the costs are decreasing so much that we can compute a lot more, and hence all this data explosion is there around us. You heard Sudesh how data is the key to many things, and you heard Raj talk about technology versus data and physics versus data. What we believe in G is that it is not versus, it is and. It is data and physics and technology that will lead to differentiated business outcomes. And what we have in GE, like any industrial company, is domain depth. We've been in the domains that we are for more than a century now. We also have strategic asset data, which makes it really powerful. I mean, you, Sudesh and Amit both highlighted examples of how data unlocks so many things. Now you add that to what I refer to as exponential digital technologies, and then it's magic. Okay, and I will show you some of the examples of how we've been leveraging this for GE, for our products and for our customers. Let me start with an example from our aviation engine business. There is an animation that is playing, and it will continue to play as I speak. So take a view of that. Each dot in this animation represents an engine. On the x-axis is cycles. On the y-axis is distress. And you can see as this engine family experiences more cycles, not all engines experience the same distress. Based on where the engine is operating, outliers start to emerge. Now imagine if the maintenance program for engines is only based on cycles, we will never be able to optimize what our customers need to really spend on their maintenance. So we did this program for one of our customers in Middle East, and it was just an amazing thing what we could do for them. 56% reduction in their inspections because we could decide which engine to open and which engine not to open. This is one of the examples of how we are using technology based on our physics and domain depth. Now, how does physics come into this example? Now, imagine flying in an aircraft engine. How many failures do you expect an aircraft engine to have? So when the bad data is very less, there is big data, but there is also small data. I mean, the number of data points that we have, which have experienced some kind of a failure or some kind of a distress, which is extraordinary, it's very important to use physics, to use those small data points to make a decision for the next engine. And that's where this power of data and physics coming together and overlaid by these exponential technologies, digital technologies, to create magic for our customers. But one more challenge arises if you think about this example. On the y-axis is distress. How do you measure distress? We have because we are in this world for long, we have physics-based models that determine distress, but it's a very complicated problem. So it's a very complicated equation, and hence what we also need is to figure out by looking at the actual component what the distress is, and that brings me to the next example that we have, which is using robotics. Now, there are two videos on the left-hand side of your screen. I want you to pay attention to the bottom left, which is on-wing component distress ranking. This is a technology that got developed in our center in Bangalore. Now, what you see is a rotation of one of the stages of the engine, and there is a camera mounted which is recording the what the camera views in that stage of the engine. Now you can see that there is a definite distress that you see, and now imagine, now this is a video that camera captured. Now take the video. Now we have to take out images of different components in the stage. Now those images have to be consistent. Now somebody has to look at that image and determine what the distress is. Imagine if we had people looking at it, humans looking at it, and trying to do that. We have 50,000 engines flying. Every engine has multiple stages. Every stage has multiple components. It's almost impossible. And hence people don't use it. But then if you could put image analytics, computer vision, Sudesh talked about using vision for operations and maintenance. I mean, the concept is the same. Only thing is, it's like so complicated, because you see, I mean, from the picture there are different shades of colors, different types of defects. What do you do? But if you crack that problem, imagine what it does for your customers and for your products. It completely changes the game. So not only do we need an understanding, excuse me, of technology, of physics, we also need to develop it in a manner that is scalable, because otherwise it's not useful. You can create an example, but you can't, till you deploy it in the field at scale, you don't start reaping the benefits, and that's a big challenge. Okay, and it can't be solved by not doing it. It can only be solved by doing it in a manner that gives your customers the biggest benefit. Okay, so that's another example that I wanted to share. Let's change tracks and let's look at a completely different domain. And this is very close to my heart because my son actually went through this. Imagine a patient going for an X-ray with a chest pain and standing in the queue, take the X-ray. Now, in many countries, I mean, including India and even in developed countries, the radiologists are very less. So now the X-ray gets taken, the report, it goes to the radiologist. Radiologist looks at the X-ray, makes their conclusion and sends it back. Now, this is a regular process. So if there were like 10 people ahead of you, your number radiologists will look at your X-ray 10 after doing 9 reviews. Okay, you are 10th in the queue. But if you have a condition called pneumothorax, and pneumothorax is a collapsed lung which happens for no reason. I mean, you can't really predict it, or you don't know why it happened. Your lung, there are bullous, things called bullous. It's like a bubble on your lung which bursts, and it bursts without any known reason, and you have a hole in your lung and it collapses. It's life-threatening if not treated in time, and you can't afford to stand in queue, but you do stand in queue because you have only one radiologist. Now, what this AI application does is, look, by scanning or by learning from the scans of X-rays taken for thousands of patients, and hundreds of pneumothorax instances alerts that this could be a potential pneumothorax and this X-ray needs to jump the queue and get to the radiologist first, not 10th. And that can save lives. And so this is one application of AI in medical area. Another similar application, I mean, there are so many. So an ultrasound is a very manual process. I mean, any of us who've gone through this know that, okay, the skill level of the operator is required is very high. And now not everywhere you have those skilled operators. So can AI help in detecting anomalies in babies, which help babies and mothers? That's what we are using AI applications for. From learning from thousands of ultrasound scans and hundreds of anomalies, getting an algorithm that can flag for the operator that there might be an anomaly and this needs detailed, deeper investigation, which can help save lives. Another application in our refinery world, there is like tens of hundreds of kilometers of pipeline, and inside there is insulation. And what happens is, because of water ingestion, there is corrosion and there is a failure in the pipeline. Now, if you have to, if these failures happen while there is, which is not a scheduled maintenance time, it can lead to a lot of losses for the refinery. Now, what our team has done is, one, figure out a technology. How can you sense water ingestion? Because sensing corrosion is too late. If you can sense water ingestion, you can probably align maintenance actions with scheduled maintenance intervals in the refinery. So it's sensing technology, it's inspection technology, and then it's data technology. So you use microwave sensing, figure out that there is water ingestion, create an alert which helps a refinery take maintenance actions aligned with maintenance intervals and not unplanned maintenance intervals. This is again a technology. All these technologies are developed by our engineers in Bangalore. So I'm very, very proud of what we've achieved. Another example, and this is like, many of you will realize if you look at the top left-hand chart, we have so many of us still use the forms on the shop floor or on people have to fill forms, and even if they type it and all, there are a lot of places where we have either historical data or even current data in this form. It's an unstructured data. You can't take decisions from this unstructured data. Can we convert this unstructured data using natural language processing to structured data? This is one example that I'm showing. I'll tell you one more example that our team utilized to save several $1 million for our aviation business. Okay, you know, there are these inspection manuals. Now, inspection manuals contain repair instructions and repair limits. Now, for different family of engines, we wanted to compare inspection manuals to say that whatever best we have for one family of engine, are we sure that we have used that repair limit and repair example for all families of engines? Physically, it's impossible. I mean, how many people will you put, and how boring that job will be? Who would want to do it? Okay, and so what we did, we deployed natural language processing for this example. And we could compare engine manuals across engine lines, and we could discover that there were several cases where the repair limits were not leveraged from our latest experience, where the repairs were not leveraged from our latest experience, and hence we were replacing parts which could easily be repaired. And we were repairing parts which did not need repair. And that saved tens of millions for our aviation business without actually doing anything. And imagine the power that this brings in. And the trick is to get insights from the data and then use those insights to make interventions. Data alone does not do anything. This journey of from data getting insights and from insights getting interventions actually solves problems. And in between, if the data is less, like for many of our products, physics is the bridge which helps us cross an insight to an intervention, because the chief engineer of an aircraft engine business will not approve if you go with a neural network response and can't explain why it is happening. They won't take a decision just because you say my neural network gave me this idea. You have to explain why, and then physics helps us to explain that. Another example, last of what I use is, now imagine the problem when all these machines are getting connected. Everything is connected. Imagine some terrorist organization somewhere hacking into a power plant and doing damage. I mean, that could be a very catastrophic failure, not only for a nation, I mean, not only for that power plant, but for a nation. Imagine if somebody hacks into it. So what we are also using AI is to create cybersecurity solutions by understanding signals early, which can detect evidence of hacking and preventing catastrophic failures for our national assets. That's another example that we are working on. Now, another challenge for AI. Okay, now look at left-hand side of this page. There are two boxes. One says, I know this is fault class 1. Please authorize to take appropriate action. The second one says the wind turbine generator might have fault 1 or 3, but not 2. I need more evidence to resolve confusion. Now, AI probably, if AI is giving you the first answer, maybe it's not appropriate, because either you had enough data for it to make that prediction, or it is making a prediction because you didn't give it any other option. So what we have started calling humble AI is where AI tells you what confidence level you have on that data, so that humans can intervene and take the right decision, leveraging all the additional insights that AI provides. Again, the use of domain expertise along with data to create AI that is actually humble. Another one, this is my favorite. You imagine, so AI will, I mean, our data solutions will get you to inspect a certain data region. But if you think about it, we can get additional information from experiments, we can get additional information from simulation, we can get additional information from our instinct-based exploration. And if you combine all that, you have a much better view of the world, view of the data than otherwise. And so we've been augmenting our data solutions with these physics-based solutions and creating a much better response system for our customers. That's also something that I wanted to leave you with. Now, there are different kinds of digital twins. I gave you an example of an asset twin. There are operations twins, process twins, industrial plant twins. You saw it in Amit and Sudhish's presentations, various examples of that. But I mean, not using them is not an option for future. We will not be competitive if we don't deploy this, because somebody else will. So if we are sitting back and waiting this world to evolve and thinking that, okay, I don't need to change, I think that could be a very big mistake, because this technology is all pervasive. This is the most fundamentally changing technology that I'm sort of observing, because this is applicable for every operation in every industry, and not using it probably is not an option. It's actually inevitable that it will come in and disturb your world. So rather than getting disturbed, take a step forward and actually start using it proactively so that you stay in line with the world, if not ahead of it. So I'll end with where I started. I mean, it's for us, it's not versus, it's and. It's domain depth and strategic asset data, which we already have. You combine it with exponential digital technologies, and we create differentiated business outcomes. So that was a little bit of an insight into the GE world of how we are using these technologies. Over to you, Raj. Thanks a lot for giving this opportunity to talk to this fantastic audience.
Thank you, Alok, and thank you for taking us through those opportunities and challenges in digital transformation. The case studies were excellent, be it from aviation, or from power, or from healthcare. And I like that concept of humble AI. And so we started with technology overtaking domain expertise, and all the three speakers today have shown why technology and domain expertise should go hand in hand, and that is very good news for consulting engineers. So we have a few questions. I think some of them have already been answered. So just to initiate the dialogue, right? You see, we are from Consulting Engineers Association of India. So consultants have traditionally been, Sudesh, if you can also kindly come on screen, and we have the new president-elect of CA, Ajay Pradhan, also with us. Ajay, if you can be on the online. And so whom does the customer prefer in a digital world? Because consultants, we've traditionally been advisors and consulting engineer, providing consulting engineering services. In this digital world, would the customer go for a turnkey solutions, or would consultants have any role to play? And why is this that way a collaboration game? So maybe Amit, if you want to take that.
Sure, Raj, thanks. Just at the onset, I'd like to say, I completely echo what Alok and Sudesh talked about. I think we should not trivialize the intelligence humans have built over years with physics and maths. Pure data without intelligence of interdependencies and various relationship of data with the physical real output is disaster in waiting, right? So I think I absolutely echo. There has to be a marriage of physics and data, and they both have to coexist. Absolutely. I think the second most important point I would like to say is we've seen the era of computer engineers. I believe this new era belongs to the mechanical, the civil, the electrical engineers with the real world physical example. And I completely agree with Sudesh's point that this is an opportunity waiting for engineers to become innovative by leveraging what our computer scientists and computer engineers have done in the last 2 decades and take it to the next level of real tangible outcomes in the physical world we live in. And we humans love the physical world. We're finding it constrained over the last 8 months to live in a virtual world, but so be it. Having said that, I think to your question, why is this different than past? And I think the simple reason to this is the rules of the game are being written. You can be part of that game and write the rules together. But the rules of the game, Industry 4.0 and beyond, are not going to be written in a closed cabin somewhere in some office, but it'll be written together with the client, with the manufacturer, with the end customer together. And that is why collaboration will have to be lived and thought and put in our mind. And why it is important, I think we've done tremendous advancements. And as they say, we are now talking about collective optimization, and collaboration only can reach us there. What are we trying to do? We've got great turbines. We've got aircrafts flying, which are performing amazing cycles of operations. We've got power plants. But what is the next level of incremental innovation and efficiency improvement requires multiple people to come together, brainstorm. So just an example, if we were to go to a plant, unless we have the operator, the manufacturer, the manager who looks at the financials, the end customer that looks at the variations in the quality, the consultants that have wide knowledge on multiple discipline, don't collaborate together in a workshop, dynamic workshop, the solutions would be piecemeal, siloed, wouldn't achieve the purpose of what we're trying to do, right? And hence, I think we must give respect to physics and data, but equally we must give respect to the collaboration of minds. Remember, 100 years back, it was the collaboration of hands that created the Ford famous story of the line, the worker on the line, the concept of line. The collaboration of hands after 100 years, I believe, is the era of collaboration of minds. Without boundaries, seamlessly across the globe, if the minds can collaborate, I think the solution that will come out will be exponentially more powerful than what we've seen in the last 3 industrial revolutions.
Thanks, Amit. Sudesh or Alok, you want to share your views?
I think, yeah, that's a perfect way to say it, because today, when I look at from a company like us, which is just budding around, earlier we used to recruit only computer engineers and say that, okay, computer engineers is the way to go and we want it for build software. But today, when I'm looking for Industry 4.0, I recruit mechanical, I recruit civil, I recruit every domain, because without a combination of that, it doesn't really, the solution doesn't come. Software engineers can only do so much, and that's pretty much it. So I see that the whole, what we call as the connected minds, is what is going to make a difference, rather than just individuals right now. So everybody has to step up and take that opportunity to drive this, and I think it's the era of engineers is what I would call it, and we need to all work together to make that happen.
Thank you. Alok?
So Raj, from my perspective, I think you asked what roles consultants can play, and do consultants have a role in this at all, right? I think the biggest role a consulting engineer can play is this cross-industry learning. As a consultant, you have a view of the world, and as an industry, sometimes we are very siloed. We don't even know, because we are set in our ways of working. Sometimes we can get too comfortable in that and not explore what others have done. So I think that's a very powerful thing of leveraging what you've seen as what has created a dramatic change in other parts of the industry or some different industry, and bringing those solutions to this industry could be a very, very important role, because that industry person will not do them by themselves, because normally we are very much keen on using some incremental productivity ideas and not think of game changers, because it is uncomfortable. So I think that is one of the key roles a consultant can play.
And I believe we have to, in developing these solutions at enterprise level, we have to be working with the customer and as our partner, and go and sit with those operating people in the plants. And despite whatever experience we have, it has to be a collaborative game with the customer, as well as all the other, whether it's a sensor manufacturer or any other integrator that is required. So I fully agree with you. There is an interesting question here, which says that in spite of having enormous potential in digital technologies to enhance the productivity, efficiency, etc., what could be the reason for a lower level of penetration, especially in not so large facilities in India? Or is this statement not correct at all? So what is the level of digital penetration that we have in Indian industries is the question.
So, Raj, I'll say that I think there is very good penetration of digital in some aspects in India. I mean, to give an example, if we can pioneer the digital currency, Paytms of the world and the online transaction, we've run the largest Aadhaar kind of a system in the world, definitely there is digital penetration. Now, how do we convert that into tangible use in the industry? Yes, we are seeing definite movement into digital when it comes to smart cities. It's slow, it takes time, it involves multiple stakeholders and a lot of capex investment as well. But smart cities is happening. We're looking at penetration of digital in water management for sure, in solar and the grid hybrid system as we call. And we are also seeing digital getting down the shop floor eventually. And we've done projects in the last 3 years of what you will see in the open coming in few next years. But last 3 years, there's digitalization of refineries and chemical plants, which has already started in India. Smart worker as a paradigm is catching up pretty fast. Having said that, yoga is very good for health. We don't see penetration across. There is a change. There are challenges. There are lifestyle challenges. There are preferences. There are perceived comfort zones. And I always say that whenever such disruption happens, the ecosystem has to come together. See, a consultant cannot drive a change unless the contractor or the owner doesn't see benefit of that change. Why to design in 3D when we can do it in 2D? We just need a drawing. We don't need a 3D model. Well, there are benefits of 3D model in mechanical or in civil, but you have to educate. You have to educate a generation of workforce managers and supervisors who have to think differently. And most importantly, what's in it for me? What benefit does it give? One of the problems with consultants and engineers is not able to articulate the benefit in the eyes of the client. And especially when you talk about new digital solution, it's our responsibility to understand the client challenge and show how the solution bridges the gap between a desire, intent, and output. So it is hard work. And any hard work will take time. But I'm very optimistic. I've seen in front of my eyes a lot of interesting stuff happening in India. We didn't have surveys using LiDAR just 5-8 years back. Today, almost all the alignments for transportation sector are based on LiDAR. We didn't see scanning in mining. It's happening across various mining units in India. We didn't see scanning for old assets as new environmentally friendly solutions are being added, whether it was in power sector, whether in sinter plants, dedusting solutions. We are seeing those environmental norms driving innovation and use of digital to do a better project management. So I think I'm optimistic. It takes time. We should not look at magic in few days. There has to be persistence. And the most important thing I like to tell people, be part of writing the rules of the new game. Because then you will drive this trend for the next many years. And so take part. There'll be some things that go right, some things that will go wrong. We have to start with pilots. So a lot of these pilots will then eventually create a full-blown solution that people will embrace. But this is the most exciting time of rediscovering ourselves.
Thank you, Amit. And there is a question here on the role of digital on climate change and sustainability, and how digitalization can be leveraged to achieve the goals of energy transition. And I will request Alok to take that.
Yeah, thanks, Raj. I'll share a couple of perspectives. One is that, we all talk about renewables as a key element of energy transition, which is true. But if you think about how much we need to gain, it is almost impossible for renewables to do it alone. So that means that we'll have to use all the available sources of energy to drive this energy transition forward and meet our decarbonization goals. Now, if that's the case, and it's hybrid, it's a gas power plant, it's a wind plant, it's a solar plant, it's some form of storage. If all have to go together, now imagine how many decisions that need to be taken to create the maximum benefit for this combination. When do you switch on your gas turbine? What is the weather going to be tomorrow, so that you can promise grid a certain rate, because you have to figure out what kind of electrons will flow in for the utility. What is the wind? What kind of quality of wind you are going to get? When do you charge your battery? I mean, you just, if you start thinking about the number of decisions you need to take to optimize everything, and the types of data, whether it's a weather data, whether it's a power plant data, whether it's a maintenance data, whether it's a dispatchability criteria data, grid forming controls data. I mean, think about the decision making and conceptualize it without digital. It's impossible. So I think the overlay of digital will make this energy transition more smoother. Otherwise, it's not. I can't even conceive it. Otherwise, it would be like 1 + 1 less than 2, and we want 1 + 1 more than 2, because we want to use a little bit more of the each one by using the decision making more optimal. So I think that's one perspective that I have. The other perspective that I have is with all the with EVs coming in. I mean, it's inevitable again, and we will have all EVs, and everybody will be producing power probably. Now imagine all that coming in, and imagine the structure of the grid and all that. How will we manage without an ability to know what's happened, and ability to take decisions dynamically, and not having one kind of standard algorithm? It won't work. I mean, it has to learn and it has to take a decision, and that is where digital will help. So I think digital will be a very key component of our energy transition, because without it, it won't be that smooth.
Yeah, we have this word prosumer these days, which is a consumer as well as a producer. So every consumer is a producer of electricity, and gone are the days of a one-way traffic of a generator and a transmitter and a distributor and a consumer. Now everybody is a producer. Every consumer is a producer. So I think the base of all this transition is to have a sound digital environment. Amit, you want to say something?
I think Alok's covered it very well. And I'd just say that I think, digital will become electricity and water as a glue. And everybody would have to think keeping this as a base. And I think all the examples Alok talked about is all about idea coming up to solve problems that we've seen for past. And yes, there was technology, there was pattern recognition, there was way to do, the entire, whether you were in drug manufacturing, you were in, medical sciences, but it was very expensive. Now the same technology is there in your hands, even sitting at home, because your phone is as powerful as some of the computers 30 years back. Now, how do we apply a problem and its solution using physics or biology or other sciences with data sciences, do a pattern recognition based approach to come out with insights and apply it across the various disciplines? And I think, grid is a great example Alok mentioned about, but so is about, access to health for everyone across the globe. Telemedicine will take a big jump if we can look at using AI, ML, as well as electronic ways of diagnostics without expensive tests, without expensive medical equipments. There are innovations coming up with retina scans are possible with your common phone, right? And they can give as much diagnostic that the most expensive retinal scans could give, right? I think eventually we'll leapfrog to really saying digital helps humanity.
Thank you, Amit. I think that was a good statement that digital helps humanity. We are already 2 minutes past 5:30. I will take a last question, and that is on construction industry. The industry itself is very much prone to change, and how will Industry 4.0 be helpful in managing the changes, and what advanced technologies can be implemented in an economical way so that every company can use these technologies. And maybe for this, we will start with Sudesh.
Yeah, I think from a technology perspective, in all areas, I think technology is available. For the construction side of it, I see that the stress analysis and all of those are now getting automated and digitized. So where a digital twin kind of a construct can be brought in to get all of those automated and done. So I see the technology applicability is existing quite a bit. But what happens is that it is the engineers who has to look at what are the tedious manual things which can be taken out, what are the time consuming things which can be taken out, what are the places where data can literally be leveraged which human brain cannot crunch so easily. So those are kind of areas where we start looking at and saying, okay, now this is the time where technology can help out to scale and make this system more seamless. So that's kind of how I see any industry going to adopt these technologies as such.
So Amit, you want to add specifically on the use of data in construction industry?
Yeah. So, construction industry has been a very sequential industry. When we have evolved into various models, commercial models, LSTK, EPCM, EPC, etc. But we've been a sequential, siloed approach, right? You've got contractors who will construct, you have a designer which will issue the drawings, you'll have a process licensor or an equipment manufacturer that will provide things, and we integrate it together. And and communication and data flow has been the biggest challenge in the industry that has caused either time to market as an impact. 95% of projects in construction world over, including India, don't happen on time. And never it's been technology, or I would say discipline sciences, that fail. It's not the mechanical engineer, electrical. It is the integration of all these elements that fail because communication is a problem. We've got contractual documents, lead and lag in terms of material supply. The manufacturer that has to supply a particular pipe or a particular equipment, the lead and lag times are not calculated properly. We've got the primaveras and the MPPs and Gantt chart, but we still cannot manage the timelines properly despite these sciences of project management. So to have a common engineering environment with multiple players working together, the possibility exists today. But is the desire and intent there? Are the contracts written that enforce the multiple contract vendors, equipment manufacturers, consultants, and clients to work cohesively in a single space? Well, good news. We've seen that happen when it comes to regulated industry. So for example, aerospace, it's regulated industry. It forces a new aircraft design to be done together with multiple contractors and vendors, or medical devices or nuclear. But construction is an unregulated local industry. We don't have global standards. So unless we in the ecosystem with consultants, contractors, and both equipment manufacturers and the end customer drive certain standardization, whether it is in the US called IPD or the BIM standards, we will not get all of us to work together. And hopefully with digital, the desire, intent, and the ability of the solution to make it happen. So in construction, simple things like drawing transmittals, collaborative engineering, which is kind of not sequential, but it is more of a parallel concurrent engineering, which is a paradigm pioneered in the aerospace days 3 decades back. But concurrent engineering in traditional civil projects was never a paradigm that people embraced. Everything was sequential, right? So concurrent engineering approaches leveraging technology to have seamless data visibility, clash detection on the fly, virtual construction simulation, use of devices for inspection, removal of quality defects, standardization, modularization to embrace precast and prefab, something we've studied for 5 to 10 decades, but really we still haven't been there, except metros in India have embraced precast. But why not, traditional buildings? Why not traditional plants? I think the equipment manufacturers have done a step ahead because as a mechanical engineer, you think in components design. How do civil engineers maybe marry some of their thinking as mechanical engineers? And mechanical engineers think like civil engineers and structural engineers. And as I said, It is a collaboration of minds. Nobody alone can do it. What we have is our strength. We can exponentially multiply that strength with the power of collaboration. And I'll just repeat what Alok and Sudesh said. It has to be 1 + 1 has to be 5. And that's what digital has the power. It's a magnifying lens. If we can get the minds together, digital is the magnifying lens that can make it happen faster and in an exponential manner across all disciplines, be it medical, be it construction, be it aerospace, defense, etc. Thanks, Raj.
Thank you. Thank you so much, Amit. And Alok, last question for you is that will digitization help in increasing jobs or decreasing jobs? And how does it help a country like India?
See, we had the same question when we thought, okay, will horse carriages, when they go, come, will there be more jobs or less jobs? I think whenever an industrial revolution happens, we all think of it in that manner, because it's not anybody's fault that people think like that, because you can't imagine the future as well as you have lived the past. So you can identify yourself a lot with the past, then you can imagine the future. But I am of the view that this will open up the doors. Imagine if IT revolution had not happened, what would have happened to our young generation, all of us? And that happened, and that time also people were telling, oh, IT revolution is coming, India, with India's population, we will be like really blown away. We dominated it. I mean, in the sense, we are the ones who are driving it for the world. And when this statistics on top of IT, along with inspection technology and along with like our domain expertise comes in, I think it's great news for India, because we will again win in this, and I believe that we will have a much better sort of participation in this growth of the world than we've ever had in any other industrial revolution in the past. It's just that it's difficult to imagine the future. It's very easy to
look at the past.
Look at the mirror.
Yeah.
Right. So that's why people are a little concerned. It's okay, and it's okay to take it carefully. But I think we need to lean into the future rather than holding on to the past, because future is much better, in my view.
Thank you, Alok, and thank you, Amit, Sudesh, and Alok for the exciting presentations, as well as taking some of the questions, and some of the other questions have been answered in the Q&A box. Request the audience to kindly take a look at it. And when I started with that statement, technology overtakes domain expertise, and is it physics versus data? I think all the speakers have been very, very vehement in stating that it's technology and domain expertise, physics and data. And they should go in hand. And it's the collaboration of the minds. And that is, I think, something that is very comforting for all the consulting engineering fraternity here. And I'm sure everybody will agree with this. And thank you so much, all of you, for your excellent presentations and taking this Q&A session in this CAI webinar series as a part of the Golden Jubilee celebrations of Consulting Engineers Association of India. I will now request our new president-elect, Dr. Ajay Pradhan, if he can come online. Ajay, are you there? Yeah, I think.
I don't think Ajay is going to be there.
Yeah, okay.
Yes, conveniently passed on that responsibility on to me.
Yeah, so Mr. Ghoshal, I will request you now to propose a vote of thanks.
Thank you very much. You see, it has, as I mentioned, one of the webinars we held, we had a sort of a tutorial on what is AI, what is ML, and what is AR, VR. Today, we have been fortunate to have speakers with us who have taken us to have a glimpse at the future. we have been exposed to the future and what is really going to happen. I think that has been a big gain for all of us. You see, to echo Mr. Alok Nanda's response to whether we are going to lose jobs or gain jobs. You see, when first computers came, the government in West Bengal, they went on strike so that computers can't be installed in any of the facilities. And today, the chief minister of the same state is running after all the IT Mughals to set up more and more facility in West Bengal. So that's the type of change which comes with any technology development. And I'm sure I agree with Mr. Nanda that we are going to see a really rosy future with this holding the hands of digitalization. And fortunately for us, the industrial revolution had bypassed India. But when digitalization is coming, this fifth stage of revolution in technology, we are holding hands with the rest of the world. So that's a great news. And it is really giving us hope for the future. Thanks to the speakers for the excellent presentations made, Mr. Amit Sharma, Mr. Sudhish, and Mr. Alok Nanda. CEI is extremely grateful to you for your presence and for your time. And it is, as I mentioned, that CEI stands for the engineering fraternity. We are all part of this movement, and we hope to gain from such interaction. And we look forward to more inputs in future so that we can educate the engineering fraternity into this new area. And thanks to the participants who had joined and who had all requested for a sort of copy of these proceedings, we will comply with that. We shall make it available, upload in our website, and you will all have access. And Dr. Malur, I can't thank you any more than, for conceptualizing, implementing, and taking it through and make it a success. Thank you very much.
Thank you, sir. Thank you for your kind words. And thanks to Amit, Alok, and Sudhish. And thanks to all the audience for being a part of this. And CEI's this quarter's Viewpoint magazine is on digitalization.
Yes.
And I will request everyone to go through that. That will get published in the first week of January. And it is also available on the CEI's website. And so